There we go. So we're going to start a new topic today, which is called organic chemistry. And organic chemistry really just is about how carbon reacts and how carbon form different molecules. And the first thing that you need to realize is how many bonds carbon makes. So if you can see my browser now, I'm just going to find a periodic table. Let's just take the first one here, should be enough. So here we have the periodic table. I just found one which is on Wikipedia. I hope it's good enough. There's not a lot of information in this periodic table, but there are the informations that we're going to need. So we can see that carbon is in group 14. So carbon has 4 electrons in its outer shell, 14 minus 10. So the electron dot structure of a carbon will look like this. So it has 4 electrons in its outer shell because it was in group 14 minus 10 equals 4. So that's how many valence electrons carbon has. And we don't draw the electrons in its inner shells. Carbon has 2 electrons in its inner shell because its element number 6 has the atomic number 6, so it has 6 electrons. But we only draw the outermost outermost electrons for the electron dot structure. So when carbon has 4 electrons in its outermost shells, it can react with a hydrogen. And a hydrogen has 1 electron because we can see from the periodic table that hydrogen is atom number 1, so it only has 1 electron, and the outermost shell must contain that 1 electron. So what we can do now is that we can form the most simple organic compound there exists by moving hydrogen there. So now we can see that hydrogen and carbon forms a bond because there are 2 electrons, and 2 electrons is a covalent bond, so they share these 2 electrons. But what we can see from this is that hydrogen only has just going to move that up there. Hydrogen has 2 electrons now, those 2 electrons, but carbon only has 1, 2, 3, 4, 5 electrons, so it does not fulfill the octet rule. So it needs more electrons, or it should lose 5, but that's not possible for this molecule here. So what this carbon can do is that it can react with 3 more hydrogens. That is a very ugly H. So it reacts with 3 more hydrogens. So it gains 2 more electrons, or it shares 2 more electrons from 3 additional hydrogens. So right now we can see that carbon actually has 8 electrons. So it does now fulfill the octet rule. That means that it's most likely a stable molecule, this one, because all the elements or all the atoms in this molecule fulfills the octet rule. So what we can conclude from this is that carbon always makes 4 bonds, and that includes both single bonds and double bonds and triple bonds. So carbon always makes 4 bonds. If a carbon does not have 4 bonds, there's something wrong, because carbon must always have 4 bonds. We can also see from this illustration of that molecule there that hydrogen always makes 1 bond. So if hydrogen has more than 1 bond, there's most likely a mistake going on, because hydrogen should always just have one bond. So it does not make double bonds or triple bonds or anything. And these are the rules that apply to the first part of organic chemistry here. Carbon makes 4 bonds and hydrogen makes 1 bond. Are there any questions now about the electron dot structure or anything? Oh, okay. Then I think we'll proceed. So the next thing we're talking about is carbon hydrides. Sorry. So a carbon hydride is, for example, this molecule here. And a carbon hydride is a molecule that consists only of carbon and hydrogens. Only carbon and hydrogen. So that does not seem like we can form a lot of different molecules, but carbon hydrides are actually, you can really form a lot of different molecules from only carbon and hydrogen. And you can find a lot of those molecules in the nature. So that means that we can form more molecules than just this one that I've drawn here so far. And let's introduce a new group, a molecule group, which is called an alkane. So an alkane is a carbon hydride. Carbon hydride. So it only contains of carbon and hydrogen, and it only has single bonds in the structure. That's the definition of an alkane. So let's try to draw some alkanes. So the first one I drew up here is called methane. That's the simplest organic molecule that you can build, the simplest organic molecule that exists. It has 1 carbon and 4 hydrogens. So the formula for methane will be CH4, 1 carbon and 4 hydrogens. But as we can see here, I've named this molecule methane, and that's because organic molecules follow some different naming rules than the ones that we are used to. Because normally we would name this molecule carbon tetrahydrogen, because there's a carbon and there's 4 hydrogens. That's not a name we're going to use. So the organic molecules, or at least the carbon hydrides, they follow a different set of rules. And I've copied this table here. It's table 15 on page 123 in your book. And I suggest that you open your book on this page. And here we can see that methane is right there. So it has the molecular structure CH4. Yeah, so that's the reason for naming this molecule methane. We can also see here that the next one, ethane, is a carbon hydride that consists of 2 carbon atoms and then 6 hydrogens. So let's try and draw ethane. Ethane there. So there's 2 carbons and 6 hydrogens. So the structure will be like this. Because now we can see that these lines here represents 2 electrons. So this carbon to the right here has 1, 2, 3, 4 bonds, and a single bond is 2 electrons each. So it has 8 electrons in its outermost shell. So this carbon here fulfills the octet rule, and the same goes for the carbon on the left, 4 bonds. And we can see that all the hydrogens only have 1 bond, so they also fulfill their octet rule, which is only 2 electrons. And this is the structural formula for ethane I have drawn here. So you're going to draw a lot of structural formulas while we're working with organic chemistry. So I suggest that you have a lot of paper that you can draw them on, because it's not very easy to do this in Paint. And if you have to upload any questions, you can just take a picture of it and then upload it in a document somehow. Because it's a lot easier to draw it on a piece of paper than drawing it in Paint. Okay, so this table I have here on the right is a table that you're going to use quite a lot until you can memorize this. So you should memorize all the different names that we have here. And if I example draw, let's try and move that down there. And if I draw a structure here, whoops, that's a carbon there, and I have a lot of hydrogens bonded to it. So these doodles here will be hydrogens, hydrogen, 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 and hydrogen. So now we can actually name this molecule just based on that table there on the right. And the strategy for naming these alkanes is that you count how many carbons are there in the longest chain. So in this molecule here, we have 4 carbons. And that actually should be enough. The hydrogens are often not that interesting. The hydrogens are just supposed to be there, but there will always be quite a lot of them. So we normally, or the strategy I use is that I just count the carbons, because that often is enough. So we can see that when there is 4 carbons, we would name the molecule butane. So this molecule here, when it contains 4 carbons in a single chain, it's butane. So it's 4 carbon in a chain. So it must be the molecule butane. So right now it's fairly simple to name molecules. And what I've drawn here is the structural formula for butane. But there's also a different method for drawing organic structures, and it's called the zigzag formulas. So the zigzag formula for butane will be this here. And the principle in the zigzag formula is that you're very lazy, and it's very easy to draw it. And the principle for the zigzag formula is that there are carbons in the ends of a line, and there are carbons in the connecting, or in the you know, where it bends. As an angle. So that will be, sorry, that will be there. So there's a carbon there, and there's one there, and of course in the ends there's also carbons. So we can see that there are 4 carbons in this structure here of butane. But we know that it's also going to use, or it's going to have a lot of hydrogens as well. And if I can figure out how to erase this. There we go. So we know that carbon must always have 4 bonds. And we can see that carbon that is right here, the carbon there. We can see that it has 1 bond to another carbon. So that's the bond there. It has a single bond there. That means that it still needs 3 more bonds. So the carbon in the end here will have 3 hydrogens on it, like this. That's a hydrogen and a hydrogen there. Because carbon always must have 4 bonds. If we look at the carbon here, so in the connecting area of the zigzag structure, we can see that this carbon here forms 2 different bonds to different carbons. So the ones there, that's single bonds. So that means that it still needs 2 more bonds. So it will have 2 hydrogens bonded to it. There we go. And if we compare it to the structural formula for butane, I can just move it down a bit. We can see that the carbon in the end there is the one that we have here. So there's 3 hydrogens on the carbons in the end, and that fits nicely with both structures. And we can see that the carbon that is in, or the 3rd carbon in the central part of the structure, is equivalent to the carbon there. And both carbon has 2 hydrogens, so that's also fits nicely. So it's just 2 different ways of drawing a structure. There's the structural formula and the zigzag formula. And the structural formula takes a bit of time drawing, and the zigzag formula is much quicker to draw, but it also implies that you have a certain chemical knowledge to actually being able to understand a zigzag structure or zigzag formula. So you should be able to do both. I think it's better to start off with the structural formulas and then try to draw them also as zigzag formulas. But there are some questions or some problems for it afterwards. Are there any questions for these zigzag formulas? Nope. So I can move on to the naming part of alkanes. Okay. So naming alkanes. I am going to use this one again. There we go. So if I draw a butane again, and I put an extra carbon here, whoops, an extra carbon there, and we have a lot of hydrogens on it. Hydrogen, 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 and so on. So let me just put the carbons in red because that's the ones that are interesting. There we go. So this molecule here is a bit more complicated to name because this molecule contains 5 carbons, but it's not pentane because the carbons are not on a single straight line or in a single straight chain. This is a branched alkane. It's a branched alkane. So the names that are out here is for the unbranched or the non-branched, I don't know what it's called, unbranched alkanes. So if they do not have any alkyl groups. So this part here, just draw that in green. This part here is an alkyl group. Alkyl group. So it's sort of a side chain that we can see this carbon, that carbon there binds or bonds to 3 different carbons. That means that that's a carbon where the molecule branches out. Sort of it forms a T. So there's 3 different ways that we can go from that carbon or to different carbons. So that's where it branches out. And the alkyl groups are also called, or the branches are also called substituents. So I just wrote that substituents are new chains that branches out from the parent chain. And the parent chain will always be the longest chain possible. And for this molecules, we actually have 2 different parent chains. There is the parent chain here, 4 carbons, but there is also the parent chain here. That's also 4 carbon, and it doesn't matter that it's not on a straight line, as long as it's as long as we don't go back, and you know, we're not allowed to make the parent chain like this, because then we would go from this carbon to that one, down to this one, and then back again and continue. We're not allowed to do that. So the parent chain in this molecule here is 4 carbons. And I think it's easiest to take the parent chain that is horizontal, because then we can stick to this one being the alkyl group. So a parent chain, so the parent chain in this molecule here is 4 carbons. And when the parent chain is 4 carbon, you should name it butane. Oh, why am I not writing? When the parent chain is 4 carbon, it's a butane of some sort. But we're not finished yet, because we know that there is this alkyl group, and that alkyl group also needs to be included in the name. So the alkyl group, we also have to name that part there, the substituent. And the method for naming alkyl group is that you take the parent name that you find in this table, and then you exclude the ane from the name. So the parent name of that alkyl group will be meth, and you exchange the ane for eel, so it's a methyl group. And you will also have to name, to put to add the position of the alkyl group or the substituents. So this is a 2-methyl group, and for that you need to number the carbons in the parent chain. So in this case, it will be carbon 2 on the left, then carbon 1 on the left, carbon 2, carbon 3, and carbon 4. And we can see that the alkyl group binds to carbon number 2 in the parent chain, so the position is number 2 on the parent chain, so it's a 2-methyl. And to form the name in the end, you put the, so the method for naming these alkanes is that naming alkanes, so it's the substituents names, and then plus the parent chain name. And you have to name, or you have to tell where the substituents are placed in the structure. So the name for this example up here will be 2-methyl butane. Okay. Are there any questions now? No? Okay. Let's try a different example. And we're going to need this table again. There we go. And let's do 5 carbons. So soon all the carbons will have 4 bonds. There we go. So let me just highlight the carbons again so that we can actually see where there's carbons. Okay, so now this structure or this molecule is a bit larger than the previous example. And we use the same strategy. Oh, by the way, I forgot to tell you, on page, if you look in your book on page 126, there's the rules for naming alkanes. So that was on page 126 in the book. There are listed some different rules for naming. Alkanes. So you should look in your book on those rules, and we can try to apply those rules to this molecule, because it's getting more and more complicated now. So the first rule is that you, or the first thing that you need to do is to find the longest chain in the molecule and apply the name corresponding to the straight chain alkane. So that will be the longest possible chain will be the 5 carbons here. Those 5 carbons. It could also have been this part here, but it's always easier to take the horizontal longest chain possible. So that means that if we were to name the corresponding straight chain alkane, it would be a 1, 2, 3, 4, 5 carbons. So it's a pentane. That's sort of the parent name, pentane. And identify the side chains and name them. So the 5 carbons that's horizontal here are the parent, or the longest chain possible, the parent chain. So the side chains will be, or the substituents will be those 2 carbons. That's the alkyl groups. And when it's 1 carbon, you take the parent name, and then you substitute the ane part of the name with eel. So it's a methyl group again. Methyl and methyl. So let me just explain it. So naming substituents. Determine the parent name. So that will be methane for those 2 up there, because there's 1 carbon in each of them. And then you remove the ane part of the name. And at the end, you add eel at the end. So it's a methyl group. Okay. That's the that's the method for naming the substituents on an organic structure. Okay, so far so good. So now we have two methyl substituents on the longest chain. So point 3 is that we're going to number the carbon atoms on the longest chain such that the side chains are attached to the lowest possible number. Oh, and I'm going to need my blue color. And there are always 2 options here that you can choose. You can either start counting from the left or from the right. If we start from the left, we will have 1 there, carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So the alkyl groups needs to have these lowest possible numbers. And here we can see we have a methyl group on carbon 3, and we have a methyl group on carbon 4. And if we add them together, plus 4, it adds to 7. And if we just try to count from the right instead of the left, we can see that we have 1, 2, 3, 4, and 5. So now we have a methyl group on carbon 2 and on carbon 3. And carbon 2 plus 3 equals 5. So 5 is lower than 7. So for this structure, we would number the parent chain from the right instead of from the left, because that will give the lowest numbers on the substituents. So that means that this is a 3-methyl group and this is a 2-methyl side chain or substituent. Okay, any questions for that part? No. So substituents, we have a 3-methyl and we have a 2-methyl side chain or substituents. Okay. Point 4 in the rules for naming alkanes is that name the alkyl groups in alphabetical order and write them before the name of the straight chain alkane. But right now we only have the identical side chains. We have 2 methyl groups, so that we don't need to think about here. And point 5, indicate the placement of each alkyl group with a number in front of the respective names. So that's the numbers that we have here, 3 and 2. And of course, 2 is lower than 3, so that should be put in front. So let me just write down here. We have methyl groups, and we have methyl pentane, because the parent chain name is pentane. And it's a 2.3 methyl pentane, and there should be a line there. So that's point 5, indicate the placement of each alkyl group with a number in front of the respective name. So that's the numbers there, point 5. And then point 6, the last one, if there is more than one side chain of the same numbered carbon, indicate using a prefix. So a prefix is either di or tri or tetra and so on. So because we have 2 methyl substituents, we're going to name it dimethyl substituents. So the name for this structure that I've drawn here is 2,3 dimethyl pentane. That's the name for this molecule. So are there any questions for the naming of this molecule? Are you able to say anything? If you're not able to say anything, you can write it in the chat. I should be able to see it there. Okay, just one last thing before you can start working on those problems. If I just draw another carbonhydrate, let's take this one, and so there will be hydrogens at the ends of those bonds. I'm just too lazy to draw them now. So hydrogens at the end of those bonds. And if we look at this structure here, and I'm going to need this one again. We can see that the longest chain possible is this one. So it's 1, 2, 3, 4, 5, 6 carbons. So it will be a hexane. Hexane, that's the parent name, or the longest chain possible name. But now we have 2 carbons in the substituents. So this is a new alkyl group that we haven't seen before. So this part here, that's a new one. And let's try and name this alkyl group or substituent. So we can see that there are 2 carbons. Oh, let me just choose another color. There are there are 2 carbons now in a single side chain or alkyl group. this is not a methyl side chain, because a methyl side chain only has one carbon in the side chain, but this one has two. So this is a new chain, it's a branched chain. And for naming this alkyl group, I can just find the rules again for naming the substituents. Oh. Here. So naming substituents, determine the parent name. So right now we have two carbons. So that means that two carbons, so it's an ethane. We can see from this table here on the right, ethane, two carbons. And then we should remove the ane part of ethane and then add eel. So it's an ethyl side chain. Okay? So just remove the ane part of the name and then add eel at the end. And you can do that with all of these. As long as it's side chains, that's the way you must name the side chains or the substituents. And then if we were to name this molecule completely, we can start counting from the left. So 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So right now we have put the ethyl group on carbon 3. If we count it from the other direction, so this one is carbon 1, 2, 3, 4, it will be a 4 ethyl. So 3 is lower than 4, so we are supposed to count from the left in this example. So it is a 3 ethyl side chain. And then we combine the parent name with the names for the substituents. So it's a 3 ethyl hexane. Okay? So that will be the name for this structure. And if you have both methyl and ethyl side chains, you should always put the ethyl before methyl, because you have to put it in alphabetical order, and E is before M. And the alphabetical order is without di and tri and tetra. So if you had two methyl groups, that should be before ethyl. Oh, sorry, after ethyl, because it's the M that you put in alphabetical order with the E here. Or it could also be a triethyl. Triethyl will always be before dimethyl, for example, because it's not the prefix that you put in alphabetical order, it's the name of the alkyl group or the substituent. Okay? So that's it for now. Do you have any questions before we end the meeting? If you do not have any questions, then start working on the problems that I've put on today's module. And I think you should at least do the first 3 problems that are on today's module. Okay? All right, I'll let me just